Hi everyone. Hopefully you've had a good start to your day. Today we're going to talk about finding the volume of prisms and cylinders. We're going to start with rectangular prisms. Rectangular prisms are my favorite because it's just length times width times height, and you're good to go. So number one, if we're asked to find the volume, our volume is going to be 9 times 17 times 24. Okay? And when I multiply those, I get 3672. And my units for this will be centimeters, and it is cubed. Okay, so area is squared, volume is cubed. And that's it. 1, 2, and 3 all look the same. So you can pause it, try 2 and 3, and see what you get here. So on number 2, my volume is going to be 10 times 14 times 4.5. Which is 630. And this should be inches cubed. Okay, lastly, number 3. Well, not lastly, but lastly for rectangular prisms. Our volume is going to be 8 times 12 times 39. And when I multiply those, I get 3744 feet cubed. And those are the ones that you hope you have a whole lot of because they're nice and straightforward. Okay, then we're going to move on to some other prisms. Okay, our formula for all other prisms is the area of our base times the height. All right, so we'll find the area of our base, we'll find the height that's connecting our two bases. So when we're talking about height for this, we're talking about what's connecting our two bases. So our base here is this triangle that I'm going to outline. Okay, and our formula for area of a triangle is 1/2 base times height. Remember, base and height have to be connected at a right angle. There's a right angle right here. So that would be 1/2 times 12 times 7.3. Okay, so that area is 43.8. And then the height of the prism is what's connecting our two bases. The side length that's connecting our two bases is this 5. So our overall volume is going to be 43.8 times 5, which is 219 feet cubed. Okay, we're going to do it again. This is a triangular prism. So this base here is this triangle. So to find my area, I'm going to do 1/2. For height of a triangle, base and height of a triangle have to be connected at a right angle, which is right here. So those two would be 11 times 5.4, which is going to be 29.7. And then the height has to connect our two bases. If I connect our two bases, that would be 16. Okay, so our volume is going to be 29.7 times 16, which is 475.2, and that'll be inches cubed. All right, so number 6, we have a trapezoidal prism. So our base is this trapezoid right here. Okay, so I'm going to find the area of a trapezoid. The area of a trapezoid is 1/2 the height times the two bases added together. Again, height has to be at a 90-degree angle. So our height of this trapezoid is 17.9. And then our two bases are the ones that are connected by our height, which would be 36 and 14. Okay, I'm going to multiply that out, and I get 447.5. And then I need what is connecting my two bases. So that would be this one right here, which is 25. So the height of my prism is 25. So my volume is going to be 447.5 times 25, which is 11,187.5. This will be meters cubed. Okay. Right, number 7 is a triangular prism. So this triangle right here, or the other, whichever one you want to pick. Either way. Okay. Now, to do a triangle, I have to do 1/2 base times height. Remember I said they're always connected by a right angle. No thank you. Undo. Okay, so they're always connected by a right angle, which would be this 28 that's marked right here as the height, but then this base right here that is not marked. So I need to find that. I'm going to call it x for now. This is a right triangle, so the way that I'm going to find x, is the hypotenuse, which is 32.5 squared minus 28 squared, and then I'm square rooting that. Okay, so when I find that, I get that value is 16.5. So my area of my base is going to be 1/2 times 16.5 times 28. So the area of my base is 231. And then the height of my prism, the distance that's connecting those two bases, is 31. So my overall volume is going to be 231 times 31, which is 7161. This is millimeters cubed. All right, last prism. This is a trapezoidal prism. This one's a little tricky. I'm going to erase this for just a second. So we are dealing with the trapezoids, and our formula for a trapezoid, the area of a trapezoid is 1/2 the height times the two bases added together. This is where that 90 degrees is, so this is our height. But neither of those are labeled, which would be the same as this distance right here. Okay, so what I need to do is I need to find, make this smaller, this value. So I'm going to have to start by finding this number first. So to find that number, I'm going to say 39.4 minus 25. Okay, so that piece is 14.4. That piece right there. Okay, and the reason why I'm doing that is because once I do that, I have a right triangle right here. and I can find x. So the way that I'm going to find x is I'm going to say the square root of that hypotenuse right here is 30.6 minus the 14.4 squared. Okay, when I do that, I get that my x value is 27. Okay, so that is the height of my trapezoid. And then my height is connecting this 25 and this 39.4. Okay, so the overall area of that trapezoid is 869.4. And the height that's connecting the two bases is this number, which is that 35. Okay, so my volume is going to be 869.4 times 35, which is 30,429 centimeters cubed. Okay, so rectangular prisms, nice and to the point. Triangular and trapezoidal, well, those are a little crazier. Cylinders are nice and pretty. We go back to having a nice, great formula for them. So our formula for cylinders is pi times the radius squared times the height. So we just need two things. We just need the radius, so from the center to the edge, and the height, connecting the two circles. So our volume here is going to be pi. Our radius from the center of the circle to the edge is 18 squared. And then connecting our two circles is 15. Okay, so pi times 18 squared times 15 is going to be 15,268.14 inches cubed. Okay, again, I just need my radius and my height connecting my two bases. So this says that the entire distance of my circle is 11. I just need this inch. So I'm going to do 11 divided by 2 to find my radius. So that would be 5.5. And then the height connecting my two circles is 21. So my volume is going to be pi times 5.5 squared times 21, which would be 1995.7 meters cubed. Okay, so cylinders, much more straightforward than trapezoidal and triangular prisms. Okay, so then we have some application problems. We have a cylinder with a 2 centimeter diameter is drilled through a triangular prism shown on the left. Find the volume of the prism. Okay, so what we're going to do is, it's kind of like your composite figures from before. We're going to find the volume of each and then subtract. Okay, I'm going to start with the triangular prism. Okay, I'm going to start with the prism. I'll cut this in half. Okay, so for my prism, I need to find the area of that base. It's a little hard to see on here, but there is a right angle right there. So our area is going to be 1/2. We do base times height. So what's connected by the right angle? A 5 and a 5. Okay, so 1/2 times 5 times 5 is going to be 12.5. And then the height of this entire prism, what is connecting the two bases, is 14. So the volume of our prism is going to be 12.5 times 14, which is 175. Okay, then I'm going to find the volume of that cylinder. Now, what it tells me at the beginning of this problem is that the diameter is 2 centimeters. So that means my radius has to be 2 divided by 2, which is 1. So the volume of my cylinder is going to be pi times 1 squared, and then the height that's connecting my two circles is still 14. Okay, so that would be 43.98. All right, and then the last thing I need to do is to subtract those two. So I'm going to do 175 minus 43.98. When I subtract those, I get 131.02, and it is centimeters cubed. All right, a diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 feet cube per hour flow rate. How many hours will it take to fill his pool? Okay, notice he's not filling his pool all the way to the top. He's filling it just to 4 feet. When we're feeling like filling something up, that's volume. So first thing I'm going to do is find the radius. So I'm going to do 27 divided by 2. When I do that, I get 13.5. Okay, so the volume of the pool is going to be pi times that 13.5 squared, and then times the height. We are only filling it to 4 feet. We're not filling it to 4.5. So we don't need this 4.5, we just need the 4. Okay, so this, when we fill it up, we get 2,290.22. Now it didn't, and this is feet cubed, it didn't ask for the volume, but it asked us how long it would take to fill the pool up. So what we're going to do is we're going to divide. This gives us 80 cubic feet per hour. So we're going to do 2,290.22 divided by 80. When we divide those, we get 28.63 hours, because it says per hour there. So this is how long it would take to fill up the pool. And that's it for volume of prisms and cylinders. So I hope that wasn't too crazy. If you have any questions, though, just let me know, and I hope you're having a great week so far.